Hello everyone, welcome back to Wild to Learn. We're coming up to the last section of the game. We're very close to the end, and I believe this is the last story segment that we're going to have. Let's pick a code. Hey, off with the twisting and turning for science sake. Okay, so my cat doesn't like this right now. Oh, I've hooked up my cat. Hopefully that's not like an electric shock collar or anything. This is, electrodes for measuring the cat. And we have cameras, we have computers processing. Let's see, what is this? Meow per slap. It's processing different things that the cat wants to do. Okay, so that looks like we have a neural network or some kind of node network. It's going to the output. The cat says meow meow meow. There's a bird outside, there's a cactus, there's a flower. I'm pretty sure the cat's looking at the bird and saying meow meow meow. Input meow meow meow, and output eat eat eat. That's pretty reasonable. Basic speech recognition. Apparently I did it. Apparently I can actually detect cat speech now. That is amazing. Okay, so the next one is going to be RNN. Our Go Meow to Human language is done, at least initially. Okay, what am I doing now? Please help. Cat speech recognition, out of ideas. Not sure if I'm on the verge of a breakthrough or completely stuck. The cat talks, but all I'm getting seems to be a random set of words. I don't know about that. Eat is not a random word, especially when looking at a bird. Is there a way to get at least 1-2 sentences out of it? Chill out. The internet has taught you well. Now is the time for ultimate trial. Try deep neural networks, ARMA, RNN, etc. They work good with speech, emotions, and predicting things like that. Should work. We need to go deeper. Who was that guy? Okay, RNN memory. For RNN to start predicting things, connect the lower pairs of sockets from left to right. Connect the lower pairs of sockets from left to right. This part of the node represents RNN's memory. Okay. In the game RNN layer node, sockets are divided into two types: base nodes and memory nodes. The node tries to calculate the next element in sequence using its previous predictions. RNN nodes can be connected to each other in a sequence in which each next node uses results from the previous node's prediction in its work. Okay, that's a brand new type of node. We'll have to figure out how that works. In the real world, this type of neural layer can remember some information about sequences of elements, letters for example. It can reproduce the style of a text and write another one using this knowledge. Okay, so input stream 2 says print. Okay, how does this work? Wait, what am I supposed to do? In the picture it looked like this. Do I connect like, no. So does it just feed like that? And then we'll train it. The nodes on the fields have reached their minimum. Okay, yeah. And I noticed it was kind of printing out hello world over here while we were training. So let's try this. OAP hello world. Okay, and apparently that was okay. RNN, this bad node can write a book. It actually can, because it outputs text. Okay, Center of Virology. Good day, I am representing a Center of Virology. We are studying a dangerous virus that is prevalent in African countries. We managed to stop its spreading for a while, but this virus is mutating at an alarming pace, and we have to start everything from scratch over and over again. We want to create an algorithm for predicting further evolution of the virus based on changes in its two structures. We have accumulated the data, but we need your help interpreting it. Wow, wouldn't this be relevant in 2020? What year are we? Oh boy, I don't even know what year we are in now right now. We are checking the calendar. Okay, where's the year? Calendar only gives me the month. 2022. Wouldn't this be relevant in 2022? Alright, proceed. Vanishing gradient. Vanishing gradient is a big issue in training deep neural networks, especially recurrent neural networks. While passing through a number of layers, the gradient becomes so small that it stops changing the weights of the network and the network stops learning. There are several ways to solve this problem. One of these is using shortcuts or gates to pull the gradient through a layer in the network. As a result of applying this method, the LSTM layer, long short-term memory, was invented. It serves as short-term and long-term memory for neural networks. Okay, I don't see what's different about this. Okay, since the name is RNN plus RNN, I'm gonna try 2 layers. So let's train this first. It requires 70% accuracy. I don't know how the accuracy is affected by this. Okay, this is minimum, but minimum is already 10%, so I don't know how that correlates with the 70% accuracy we're getting. So if we do this, I imagine the accuracy is going to be too low. Yeah, this is not even close. I don't know what's happening. I don't know how it even determines this accuracy, but since it says, you know, RNN plus RNN, I am gonna try this. I don't really know what's happening though. Okay, looks like 2 layers gets me enough stuff. And also I don't know what the point of connecting these is. I wonder if you can do something like... Oh, no, I guess you can't connect in between. Yeah, what about this one to this one? No, you're not allowed to do that either. Yeah, it looks like that one is the only one you can connect it to. So I'm not sure what the point of connecting that is. Yeah, you can connect that. Cannot connect anything else. Yeah, this is kind of strange. Maybe this bottom part is just a visual representation of its internal stuff, but then I also don't understand how the accuracy works, because it says 10%, but then it wasn't meeting the 70% requirement. And then I don't know why if you connect 2 of these in series, then it increases accuracy, so I don't know. Looks like it's outputting some RNA sequences. Anyway, next one, important numbers. Good day, this is interpool. I don't know what interpool is. A thorough investigation which we've been conducting for almost 5 years has almost led this game just has a lot of typos. Has almost led us to the leaders of the Russian mafia. Unfortunately, our agents were compromised while transferring sensitive information, phone numbers of the head mobsters. Our specialists have managed to save most of the information, but it was not enough. Many numbers are corrupted, missing 1 or a few digits. We need a working algorithm that will help us recover those. It can be the key to finally closing this case. Okay. It kind of has to depend on the type of corruption. If the digits are completely missing, then there's really no way to predict the missing number. It's like saying my house's number is 17 something 34 and then asking you to predict what that something is. It doesn't work that way. Okay, doesn't seem like there's a whole lot we can do, right? So train this. And then if it's not enough, I guess we'll just have to Like that doesn't seem enough, so copy paste. We'll just hook these up, and if we need 4, I guess we'll need 4. I don't know. Okay, yeah. So the accuracy is still not good enough. Yeah. Okay. Yeah, I could do that. I don't know if that does anything. Yep, apparently it does for accuracy. Is it going to be fast enough? Yep, apparently it is fast enough. Yeah, so this is really weird. Like, I still don't understand how this is supposed to work. Yeah. Okay. List of important. I'm pretty sure I finished that, but okay. Let's just run it again. This is kind of bizarre. And it doesn't look like you can do anything interesting with this anyway. It's just one input, one output, and then you connect a lot of them to make it more accurate, as far as I can tell. That's all you can do with it. These. Okay. For that, let's go to our eBay, because we can buy a lot more stuff now. A turquoise Lacoste polo, merge with a wave. So I got a new shirt. Oh, we got an achievement, so it seems like yep, we have gotten every single item in this category. We have gotten every single node, I'm pretty sure. Yep. Hardware. We should be getting close too. Yep, just the last two. Intel J7 increases work speed and transfer speed, and 2TB SSD increases nodes work speed and DLL slot. And we got another achievement. Okay. And then we get more cats. Sneakers Hunter, he hates portals. And then Iron Cat, Mastermind Cutie Heartbreaker, Born Hunter. Okay, Cataholic, we got the achievement even though we're missing a cat. I'm gonna look into that, see if we can get that for next time. Okay. Looks like that's what we need to do here. Let's go to the tree. Rorex Company. Rorex Company, hello. I am working for the well-known Rorex exchange company. We are engaged in currency transactions. I am leading a project, the main goal of which is to accurately predict the exchange rate of a certain currency at the time of our need. The forecast should be made for a short-term period. Can you write such a program? Okay, we have ARMA. In the game ARMA, this node predicts the continuation of numerical sequences. Additionally, ARMA highlights the output elements with colors if the quality of prediction is high. Multiple ARMA nodes are required to achieve this quality sometimes. Okay, so it seems like it's the same as the RNN nodes and we can chain them. In the real world, ARMA is a special machine learning model designated to work with time-dependent numerical data. It can predict future indicators basing on a set of previous values. It is often used in economics, for example, to predict exchange rates. Okay. What is this? Red and green. Okay. I'm thinking because in the tutorial it showed it outputting green and red stuff highlighted differently depending on the quality of the items. As you can see now it's starting to output red and green stuff. So maybe if we do this and then do a decision tree. Reds are coming over here. Now we're starting to get some green. Okay. Yeah, I have no idea what this is about. So initially, before it starts understanding the sequence, it was outputting gray. And then after it understands sequences, it started outputting some red initially. And then as its model got better and better, it started outputting more green. So I understand that part. That's what's happening with the model internally. But then I don't understand. Yeah, I guess this is just sorting out the bad predictions from the good predictions, but then there are also gray ones, which I can't even filter. So that's kind of weird. See, now the gray ones are, I guess the gray ones also count for red. And then, yeah, this is weird. It's kind of funky. I don't know what's happening here. Okay, weather predicting app, that's the startup, so you know what we're gonna do. Weather predicting app. Dear Sir or Madam, we're living on a subarctic island with the potential for turning into a luxurious spa resort. Our location implies a very cranky weather. It changes each 15 minutes from ice storms to thunderstorms. People sometimes get blown off the island. That's pretty extreme. Not good for business. We need an algorithm which would predict the weather's next twist, so we could recommend proper measures to cope with nature's surprises. Heavy kettlebells for walking in the wind might be a great option to offer our clients. Okay. Okay, so red, mix, blue, green, and blue. And we have ARM and Perceptron color. Okay, I don't know what's happening here. Red and green with 20% accuracy, so you know, why not? We don't need to fulfill all the output streams anyway. Test run. Are there gonna be any blues coming out? Yeah, no, there's never gonna be any blues. So blue has 0% accuracy right now. Arma, okay, we might need more because it's not getting anything. The only gray is coming out, so we're not actually getting a model. Okay, so first of all, let's do multiple Arma. I don't know how many we'll need, but we're just gonna output whatever into the red and green so it accepts everything. We don't want anything here. Pure red and pure green is kind of pointless. So hopefully it's gonna start, yeah, it's gonna start outputting, oh, it has blue. There is blue. But seriously, who cares, because we have the accuracy already. And then this one doesn't have balancers, so we can't even parallelize anything. So I'm pretty sure this is as good as we can get. Release. Yep. And then we're not handling all the users, but as I said, we can't parallelize it anyway, so we're just gonna let it go. Yeah, as with all these tasks, I don't really know what's going on with the nodes and what makes them good or bad. So I'm just kind of going along with the mechanics that the game is showing me. And so far it seems to be working okay, so I'm not complaining. I just wished it had more resemblance to what data scientists actually do, because it was saying that in the game had that in its description. It's saying playing this game is actually what data scientists do. And that's why it's fun, but that Arma thing had nothing to do with anything really. Okay, negative income, we're gonna cash out. Yeah, we don't have anything to buy anyway, so we have 242k. That's pretty good. Alright, so I think I'll end the episode here. There's one more task coming up, and then we have another story segment and something hidden. I will do that in the next episode. So that'll be it for this episode. Thanks for watching, hope you enjoyed it, and see you for the finale next time.